Before formulas, before calculus, there was a question. What does it mean for something to move? The answer feels obvious. We walk. Rivers flow. Planets cross the night. An arrow leaves the bow and travels toward its target. But some of the greatest ideas in mathematics were born when an obvious answer suddenly stopped being obvious. This is where our story begins. Imagine a single arrow in flight. It begins here, and a moment later, it is there. Between those positions, it seems to pass smoothly through space. Nothing could appear simpler. A bow releases. The arrow crosses the air. It reaches the target. Surely this is motion. And yet, more than 2,000 years ago, that simple flight became the center of a disturbing argument. Now freeze the image. In this one instant, the arrow occupies one position. It is not visibly crossing a distance. It is simply there. Freeze another instant, and another. Each frame contains a perfectly still arrow, located somewhere in space. If time is made only of such instants, and every instant contains only stillness, then a dangerous question appears. Where exactly is the motion? This was the challenge associated with Zeno of Elea, whose paradoxes reach us through ancient discussion, especially Aristotle. His paradoxes were not childish tricks. They attacked the very ideas of motion, plurality, space, and time. Our senses say the arrow moves, but reason, pushed in a certain direction, seems to break the journey into nothing but motionless moments. Zeno had turned motion into a crisis of thought. The arrow was not Zeno's only challenge. Consider a traveler crossing a finite path. Before reaching the end, the traveler must first reach halfway, then half of the remaining distance, then half of what still remains. Before completing what remains, another halfway point appears, again, and again, and again. The destination is finite, but the divisions seem endless. 1/2, 1/4, 1/8, 1/16. The journey appears as an infinite procession of smaller steps. Each new distance is smaller than the last, but there is always another one after it. How can infinitely many stages be completed in a finite journey? This is the wound Zeno leaves open. Reality seems to move, but infinity makes the explanation feel impossible. Zeno did not possess modern calculus. We must not place later mathematics in his hands. But today, we can use modern notation to see why his challenge mattered so much. Write the traveled distances as 1/2, plus 1/4, plus 1/8, plus 1/16, and onward without end. The number of pieces grows forever. The central question becomes sharper. Can an infinite process approach a finite result? After the first step, the traveler has reached 1/2 of the path. After the second, 3/4, then 7/8, then 15/16, then 31/32. The total does not wander away. It approaches 1. The divisions never stop in the idea of the process, yet the remaining gap becomes smaller than any fixed distance we choose to demand. Much later, mathematics would give this kind of approach a precise language, the limit, not because Zeno had already solved motion, and not because every philosophical question disappears in a formula, but because the infinite could now be approached with discipline. A gap can shrink, a sequence can converge, an endless refinement can carry us toward a definite value. That idea will become one of the foundations of calculus. Return to the arrow. It flies again. This time the flight carries a new tension. We now know that motion hides questions about time, infinity, and approach. The paradox has not given us calculus yet, but it has opened the door. For mathematics to understand curves, motion, and change, it first had to learn how to stand at the edge of infinity without collapsing into confusion. And that brings us to the next question. If endless division creates a crisis, can endless refinement become a method? Can a curved shape be trapped by better and better straight-edged approximations? Can infinity be used, not merely feared? In the next chapter, one of the greatest mathematicians of the ancient world will turn that question into geometry. Next, Archimedes and the geometry of infinity.